Last class we have done with conservation of angular momentum when a particle collides with a rod. We need to solve a few problems based on this, right? Consider this. This is a thin rod of length L. thin rod of length L. They're telling you lies on a smooth horizontal table. Lies on a smooth horizontal table. Smooth horizontal table. Agreed? This lies on a smooth horizontal table. A particle on the table strikes the rod perpendicularly at one end and the particle stops. Particle strikes the rod perpendicularly at one end and the particle comes to rest. Right? First question they asked you was, find the distance traveled by the center of the rod. Distance traveled by center of the rod by the time it rotates by 90 degrees. Second question. If capital M is 4 times small m, show that small e is equal to 1. It is a perfectly elastic collision. Or vice versa, if it is an elastic collision, show that capital M is 4 times smaller. So it is small m. Small m is the mass of this particle, capital M is the mass of the rod.
Sir, V naught is the given velocity, right?
And V naught and omega are variables, not given.
Oh, okay.
Not given. V naught and omega are variables.
Sir, in initial speed of the particle
Initial
is
speed.
Not given.
okay.
Okay.
Initial speed of the particle is not given.
So where does the particle strike?
At one end, perpendicular to the rod.
Oh, sorry, sir. Didn't see.
Shall I? Firstly, assume this to be small m and the velocity is u. Right? Conservation of linear momentum is permitted because the rod is not hinged to any point. Mu plus 0 is equal to capital M V naught is my first equation. Mu is capital M into V naught. Mu is capital M into V naught. Conservation of linear momentum. Conservation of angular momentum, you want to conserve about which point?
Center of rod.
Center of the rod in the yeah.
Would you prefer point of contact? It's okay. Let's solve you the center of the rod slightly above in 8. Center of the rod in 8 at rest. When the rod goes ahead, the point should remain there. Mu into L by 2. Mu into L by 2 plus 0 is equal to, this came to rest, 0 plus angular momentum of the rod about this point. How do I get angular momentum of the rod about this point? Angular momentum of the rod about center of mass, ICM omega, plus angular momentum of center of mass with respect to this point is 0. See if all of you are convinced with this. Initial angular momentum mu into L by 2. Final angular momentum of this with respect to this is 0. Angular momentum of the rod with respect to center of mass is ICM omega. Plus angular momentum of center of mass with respect to this is 0.
Yes, sir.
Now, MUL by 2 is ML square by 12 into omega is my second equation. 6 and L. Omega is 6 mu by capital M into L. This is equal to theta by T, pi by 2 by T. Why? I am finding out the time after which a rod rotates by 90 degrees. This formula I can use only if omega is constant. Yes, after collision, omega is constant. After collision, omega is constant. Time will be pi by 2 divided by 6 mu into capital ML. This is the time after which rod rotates by 90 degrees. In that time, what is the distance moved? X
Into
is
V naught.
equal to V naught into T. Why V naught into T? This I can use only if V naught is constant. Yes, it is. After collision, V naught will remain constant. V naught, which you will get from here, mu by capital M. Mu by capital M into time is pi by 2 capital ML by 6 mu. Mu pi L by 12 is the distance moved by the center of mass of the rod. By that time, the rod rotates by an angle of 90 degrees.
So here why didn't we directly use that capital M by M is 4?
That's the second question. This is the first question.
Oh, sorry.
In question mein he is asking you, if it is a perfectly elastic collision, show that capital M is 4 times smaller. Can I rub the board?
Yes, sir.
Now in the second question, what they are asking is, what if it is a perfectly elastic collision? What is the velocity of this? L by 2 omega plus V naught. Velocity of this is 0. E is equal to L by 2 omega plus V naught minus 0. This came to rest upon initial velocity of this minus the velocity of the rod. Velocity of this point of the rod minus initial velocity of small m upon initial velocity of small m minus this. You are telling me E is 1. L by 2 omega plus V naught by U. Bring U to the left. Substitute omega from here. 6 mu by capital ML. Substitute and see what are you getting as the answer. Omega, you will substitute this quantity. V naught, you will substitute mu by capital M. Bring U to the left and simplify the equation. Tell me what you are getting.
So we have to prove the ulta of this.
Either way, it is the same. I have taken elastic collision and proved capital M is 4 times small. You substitute capital M is 4 times small m and substitute there, you will get equal to 1. Capital M is 4 times small m, substitute karo and substitute omega here. You will get E equal to 1.
Done, sir.
Now listen. This is a thin rod which is rotating in clockwise direction with omega naught is 6 radians per second. Hinged about this center. Hinged about this center. Particle of mass small m moving with a velocity of 6 meters per second. Small m ka mass is given to be 1 kg. Mass of the rod is 2 kg. right? Length of the rod is 1 meter. Length of the rod is 1 meter. Coefficient of restitution of collision between these two is 2/3. Small e between these both. Right? Now listen, make one small correction. This is not hinge. It is kept on a smooth table. Smooth horizontal table kept on a smooth horizontal table, right? And it is spinning in the clockwise direction with 6 radians per second when small m collides with the rod. When small m collides with the rod. Small m is 1 kg, capital M is 2 kg, length is 1 meter, small is 2/3. Right? He is asking you velocity of the rod just after collision, velocity of small m just after collision. Find the velocity of the particle and the angular velocity of the rod just after collision. Write down the statement. Find the velocity of the particle. Find the velocity of the particle and the angular velocity of the rod.
Sir, it is not hinged.
Not hinged. It is kept on a smooth horizontal tape.
Okay, sir.
Find the velocity of the particle and the angular velocity of the rod just after collision. Shall I?
The 5 minutes.
Now listen. Just after collision, this is omega naught. Just after collision, I assume the rod continues to move in the forward direction with an angular velocity of omega. Small m will move with the velocity. Call this V naught. Omega naught is already used. Omega, call this V. First equation will be conservation of linear momentum. Small m into 6 is equal to, this is capital M into V naught plus small m into V. What is capital M? 2 plus V. This is my first equation. 2V naught plus M into V. Agreed? But to avoid confusion, call this VC. Call this VC. Right? Now, what will your second equation be? Conservation of angular momentum. I would prefer
Point of contact.
point of the rod, point at which contact happens. Initial angular momentum is 0. Final angular momentum of small m is 0. Now, angular momentum of the rod about this is angular momentum of the rod about center of mass, ICM omega. plus angular momentum of center of mass with respect to this point. That will be capital M VC into L by 2, both clockwise. Angular momentum of the rod about center of mass plus angular momentum of center of mass with respect to this point will be capital M VC into L by 2. Right? Capital ML square by 12 into omega with a negative sign is MVC into L by 2. Angular momentum of the rod about this particular point is angular momentum of the rod about center of mass plus angular momentum of center of mass with respect to this point. Omega is minus 6 VC by L. Omega is minus 6 VC by L. Right? This is my first equation. Bolo.
So, sir, initially, so why did you take the angular momentum of the rod with respect to P as 0? सर उसमें भी तो ओमेगा है ना, तो ICM ओमेगा नॉट क्यों नहीं होगा?
My bad. I committed a mistake. Angular momentum of small m is 0. Angular momentum of the rod about this point is angular momentum of the rod about center of mass. My bad. This will be ml square by 12 into omega naught is given how much?
6.
6, sir.
Will be equal to ml square by 12 into omega plus capital M VC into L by M. 6, 6, 2. This will be L is equal to L omega by
See with a
6.
negative sign. I mean, anti-clockwise.
All clockwise.
Oh, okay.
All clockwise. Second equation. With respect to center of mass, clockwise. Now, with respect to this point, clockwise plus clockwise. Everything is clockwise.
Okay, sir.
This doesn't dimensionally appear good for me. Okay, omega you already substituted as 6. Okay. Omega naught you substituted as 6.
Yes, sir.
Now I have two equations but three variables. V, Vc, omega. That means you need a third equation. Small e, how much is that given? 2 by 3. Have a look at this. Velocity of this with respect to center of mass will be L by 2 omega backwards. So I'll take this velocity as Vc minus L by 2 omega. Are you able to see this velocity? Velocity of this with respect to center of mass is L by 2 omega backwards. So this will be Vc plus L by 2 omega minus V upon 6 minus 0.
Sir, VC minus L by 2 omega, right?
Vc minus L by 2 omega. This minus this upon 6 minus 0.
So why 6 minus 0 while rotating तो नीचे वाले point का भी velocity होगा, right? So
Yes,
in the
yes,
opposite direction.
right. It is not 6 minus 0. It is 6 minus L by 2 omega. Minus of
It will be
minus.
plus, right?
6 plus.
Minus of minus. Right. How much are you getting omega as? Omega and V is what they asked. Try your answers. मैंने सिंप्लीफिकेशन छोड़ दिया, आप लोगों ने भी छोड़ दिया, आराम से बैठे हुए. Are you people there? Am I connected?
Yes, sir. Yes, sir.
Yes, sir.
L is the length of the rod. L is the length of the rod. Listen to the question, kid. It is hinged at the topmost point. It is kept in the vertical plane. Small m strikes the rod at a distance of b from the hinge with velocity v0. Elastically, E is equal to 1. First question. Find B for which find the value of B for which no horizontal reaction occurs at the hinge. No horizontal, or find B for which NX is 0. Horizontal reaction. This should be NX. Your requirement of NX should be 0. At what distance from the hinge should small m strike? Elastically, such that NX will be 0. Second question. For what value of small m by capital M? For what value of small m by capital M? Small m comes to rest if small e is half. Find the value of small m by capital M, for which small m comes to rest just after collision, if small e is half. For the first bit, small e is 1. Will you people try?
Yes, sir.
Yes, sir.
Yes, sir.
1. And I am waiting.
So I didn't understand the second part of the question.
First part हो गया आपसे?
No, sir. What?
तो फर्स्ट पार्ट करो ना यार पहले. Remember, we told you nx is 0, not ny. आंसर तो बोलो, इतना देर भी नहीं लगता है. What are you people doing? Listen to the key catch in the problem. It doesn't take so long for the first bit. You people are on the wrong track. Nx is 0, so there is no horizontal force on whole of the system put together. Do you agree with that?
Yes, sir.
No horizontal force on whole of the system put together implies I can conserve linear momentum.
Yes, sir.
If this is omega, Vc will be L by 2 omega. Why? Velocity of center of mass with respect to the hinge is L by 2 omega. Plus velocity of the hinge with respect to ground is 0. Agreed?
Yes, sir.
After collision, let me say assume that this is rotating with an angular velocity omega. I'll draw this diagram separately so that you people are clear. I'll keep this diagram clear. This will be L by 2 omega. This mass is moving with, let me take V1. So this will be B omega, velocity of this point. After collision, this is the scenario. Say something.
Yes, sir.
Omega is the omega of the rod. Velocity of the center of mass with respect to ground is L by 2 omega. Velocity of this point will be B omega. Firstly, conservation of linear momentum. mv0 is equal to mv1 plus capital M L by 2 omega. mv0 is mv1 plus capital M L by 2 omega. Capital M you gave me as how much? 3 times small. So 3 small m. Cancel out this. V0 is V1 plus 3 omega L by 2. My first equation, conservation of linear momentum in the horizontal direction, could be done because you gave me nx is 0. If nx was not 0, I cannot conserve linear momentum. Angular momentum, I'll have to conserve only about this point because there is ny. Then some students may say they'll select some point somewhere here. You're welcome because ny is passing through that point, mg is passing through that point. If you select a point on the rod in air which is at rest, I am okay with it because ny will be passing through. But avoid controversy. Take the angular momentum about the hinge. Initial angular momentum about the hinge. mv naught into b. mv naught into b. Anticlockwise. Anticlockwise. Right?
Yes, sir.
Yes, sir.
Final angular momentum about the hinge. ml square by 3 into omega. Anticlockwise. I about this into omega. Pure rotation about this. Minus small m v1 into b. All are anticlockwise. I put negative about the hinge. Small m v1 into b. Capital M is 3m. I'll write it here itself. 3 gets cancelled, m gets cancelled. Minus v naught b is minus omega L square minus v1b. This is my second equation. First equation, second equation. Will I be able to simplify for the two variables? I need b in terms of L. I need b in terms of L. Simplify and tell me how much is b. I'm waiting for it.
Sir, we'll need one more equation, no? We have
Yes,
two
sir.
variables. Sir, the
Elastic slab.
Sir,
equal
E
to
equal to 1
yeah,
we will use here.
Did he give us that? E equal
Yes.
to 1. Have a look. B omega minus V1 upon V naught minus 0. This is my third equation with E equal to 1. B omega minus V1 upon V naught minus 0. Put E equal to 1.
Sir, can you once again say why you conserve the angular momentum about the hinge?
Ny is passing through it.
Yes, sir.
Have an Ny. So best to take it about the hinge, you will be safe.
Okay, sir. Sir, but if we take a point where, like, where the point of contact, so there the angular momentum of both small m will be cancelled, right? I mean, it will be 0.
Yes. Yes, if you take point of contact, we are okay with it. And Ny is also passing through that
Yes,
particular point. We have no issue with that.
Yes, sir.
Simplify and tell me the value
Sir,
of
12 by 3.
how much?
12 by 3. 12 by 3.
12 by 3. All of you should get the same answer.
Sir, is it correct?
Yes, 12 by 3 is correct.
Sir, but it took a lot of time. Like you said, it won't take time. But I got 4 equations. That's a different thing.
So third equation wasn't needed only. We could
Yes,
have solved using the first two only. In the
Why did
in
they
the
ask for
first
third?
what?
Why did they ask for third then?
I don't know. I solved it using the above two equations only.
सर सेकंड वन में b मल्टीप्लाई कर देंगे तो फिर इजीली सॉल्व हो जाता है.
Yes, sir.
Now, when it comes to the second question, he changed the value of small a. Now, in the second question, there is no restriction that nx should be 0. If nx is not 0, I cannot conserve linear momentum. First equation will not come together. This is the first equation. In the second bit, you changed the value of e. Can I rub the board?
Yes, sir.
You changed the value of b. Now capital M is not 3m. You are asking me for small m by capital M, such that small m comes to rest of the collision. Small m comes to rest. Right? Now small
Yes, sir.
e is half. This is what you're telling me. Small e is half. I cannot conserve linear momentum in the horizontal direction because now there is no guarantee that nx is 0.
Yes, sir.
All I can do is conserve angular momentum, right? But first let us put small e. Half is equal to b omega minus 0 upon v naught minus c. B omega by v naught is half, right?
Yes, sir.
Now, conservation of angular momentum about the hinge. Small m v naught into b plus 0 is equal to capital ML square by 3 into omega. The angular momentum of this will be 0. This is my second equation. Omega value from here you substitute, here you will get small m by capital M. Two equations, and I want small m by capital M. Verify if you are getting. Okay, to simplify, where should we take the answer? Simplification कर रहे हो? Wait कर रहा हूँ तुम लोगों का.
Sir, L square upon 6B square.
Perfect. L square upon 6B square. Simplify both, eliminate omega and V naught, you get small m by capital M as L square by 6B square.
Done, sir.
Now listen, there are two rods AB and BC, or rather A and B, however you call them, each of length L and mass M and 2M. As shown in the figure, hanging in the vertical plane. A point mass 5M moving horizontally hits the lower end of the combination and sticks to it. Hits the lower end of the combination and sticks to it. Sticks to it after collision. Sticks to it after collision. Right? Now write down this question, last line. Find V naught for which the system would just rise to the horizontal position. Find V naught for which the system would just rise to the horizontal position.
So like just after collision, it'll go in the horizontal position.
I didn't get you.
So
Means
just
that,
after the collision, it'll go in the horizontal. Okay.
After collision, it will rise to the horizontal.
Okay, sir.
Find V naught for which the system would rise to the horizontal position of the collision. And 5M sticks to the rod here at the lower end.
The length of both the rods are same, right?
Yeah, length of both the rods is same, L and L. So total length of the combination is 2L. I want the final answer. I'll wait. I have patience. You people don't simplify. I will sit and wait. I want the value of P naught.
V naught, no?
V naught. Find V naught for which the system will rise to the horizontal position. (27/2G). Yes. First of all, calculate the moment of inertia of this body about the hinge. Why do you need that here? Because I'll conserve angular momentum about the hinge.
Yes, sir.
5m V naught into 12 anti-clockwise. Once it sticks to this, I assume it's rotating with omega. I about 2 into omega anti-clockwise. This is my first equation.
Yes, sir.
Initial angular momentum, final angular momentum. I about O, how will you calculate? I about O is ml square by 3 plus moment of inertia of this 2m mass about that. First to find out about its center of mass. Plus moment of inertia of this 2m about O, how do I get? First to find it about its center of mass. 2m L square by 12 plus 2m into d square. What will d be? L plus L by 2, 3L by 2 whole square. This is moment of inertia of the 2m rod about O. Moment of inertia of the m rod about O. Job not yet done. Plus 5m sticks to this of the collision. 5m into 12 whole square. This is I naught, which I will have to substitute here. This should turn out to be 25 ml square. 5m V naught into 12, 25 ml square into omega. M will go 1, L will go. This will become 5. Omega is 2 V naught by 5L. With this angular velocity, system should come to the horizontal position. That means what is the kinetic energy? Half I about 2 into omega square. I about 2 is known to me. Should be equal to the rise in potential energy. mg into L by 2, 2m into g. This center of mass came up by 3L by 2, 5 mg into 2L. Small m raised by a height of L by 2m raised by a height of 3L by 2. 5m raised by a height of 2L. Where from did that potential energy come? Should be coming from this kinetic energy. Substitute this omega here. I get the value of V naught. The answer should be 27 by 2. I think GL.
Sir, for the kinetic energy, sir, shouldn't 5m V naught also be there?
This kinetic energy is for the complete system. You took 5m along with I naught. 5m along with I naught. So whole of this is one system. After 5m 6 square.
Sir, तो
So this
final
half-
minus initial होता है ना?
After collision, this is the kinetic energy here. This is the total
Yeah.
kinetic energy.
Yeah. Okay, sir.
After collision.
Sir, I have a silly doubt.
Hmm.
Sir, why can't we conserve initial kinetic energy, that is like the kinetic energy with 5m it was coming, and then the final potential energy?
Inelastic collision hai. It is sticking to the rod. Inelastic collision. During collision, some energy is lost.
Yeah, sir, sorry, sir.
So I'm getting 2 outside of the root.
Yes, sir. 2 is coming outside of.
Who is outside? Okay. I didn't do this. So there's every possibility of that. But all of you should get the same.
Yes, sir, even I have got.
1994 JEE question on this subtopic is the best of the questions that JEE people could ask as far as conservation of angular momentum is concerned. That I will discuss in the next class. We will take another 2 more lectures to complete angular momentum. Actually, few of the problems done in the class today, generally we give as homework. But I thought I'll do it in the class itself for a change. So I gave you people
Sir,
surplus
थोड़ा-
time to solve this.
तो थोड़ा एक्सटेंड करके दे दो ना वो प्रॉब्लम.
Nahin. Fine. So see you people in the next class. When is the next lecture?
Next week.
Next week.
Okay, this week we don't have one more lecture.
We have a doubt lecture. Sorry, doubt lecture is also not there.
We
Oh,
had a lecture on Monday and today.
Yes, sir.
oh. It's okay. No issue. See you people in the next class. You will have homework, huge homework walking in after the next class.
Okay, sir.
Next
Yes,
two
sir.
lectures, lot of homework will walk in. We'll deal with angular impulses also in the next class. Right?
Okay, sir. Yes,
See
sir.
you people in the next class. Good
Thank you, sir.
day.
Bye, sir.
Bye.
Bye, sir. Thank you, sir.
Thank you,
Thank you,
sir.
sir.
So,